Okay, so in this problem, we have an end circle inside of a sector area. And we know that the sector itself has a central angle of 60 degrees, and that the big circle has a radius of 16. So let's see if we can cut this figure into shapes that we can actually do some math with. So what I'm going to do is I'm going to put in a bisector here going through the center of the little circle, and then I'm going to put another segment in so that that forms a triangle. I'm going to do the exact same thing to the other side. So now I have two right triangles with a sector area on the other side. I know that if this is a bisecting segment, then this angle is 30 and that angle is 30. And if this is a right angle, then this angle would be 60 and this angle would be 60. And I know that these two triangles inside of here are congruent by angle, side, angle. Angle, side, angle. And I know that the big triangle then would be congruent by the same logic. So if these two triangles, big triangles, are congruent, then that means that that piece and that piece by CP/CTC are congruent with one another, which means that these two triangles here would be 60 and 30. So those two triangles inside would be congruent to one another. So because all of the angles are congruent, you have angle this side and that angle, and you have angle this side and that angle. So these two triangles have to be congruent. So that means that that line is bisecting this longer radius. So that means that this side is 8. That side is 8. And I know because my circle isn't perfect that it doesn't look that way, but it has to be congruent. It's not drawn to scale. So that means that this side is 8 because the two little triangles inside of there are congruent to one another. So now that means that I can find that side. Let me redraw that triangle a little better. So this is my inner triangle. This is 30, this is 60, that's 90, this side is 8, and that side is x. So I can say x is equal to x root 3 is equal to 8. So that means that x would be equal to 8 root 3 over 3. And that's my radius.